Alright guys, today we're going to look at the end of 7b, which is still our remainder theorem, which we haven't actually talked about yet. We really only talked about polynomial division. So now we're actually going to apply polynomial division into what we actually want to use it for. Okay? So a root of a polynomial is where the polynomial, we're going to like allow it to equal 0. So it's also like your solutions or your x-intercepts. All of these things are the same. So where that graph would cross the y-axis. We call these, again, the solutions. A factor is kind of like the opposite of a root. If x equals k is a root of the polynomial, right? So if x equals k is your solution, then your factor is x minus k. We saw this yesterday when we were looking at synthetic division, right? If it was x minus k, we would change the sign to, right, if it was minus to plus, right, and x equals k, and that's what you use to do your synthetic division, okay? So you can easily switch between a factor and a root. The remainder theorem, when you divide a polynomial, right, by x minus k, right, the remainder is equal to f of k. So if I'm trying to find the value of my function at a certain point, I can use division. And we're going to look at some examples. Our factor theorem, right, it is a factor if your remainder is 0. So when you divide, you get a remainder of 0. Then it is a factor. And that makes sense because it's just like factors of numbers. When I think about like what are the factors of 12, right, 4 is a factor of 12 because it divides evenly. Right? I can do 12 divided by 4 is 3. There's no remainder. Same thing with polynomials. Okay? So if it is a factor, there's not going to be a remainder. So let's look at example 1. Okay. Example 1. Determine if 4x minus 3 is a factor of 4x cubed minus 16x squared plus 17x minus 6. Okay, the first thing I have to decide is, am I going to use long division or synthetic division? Okay. Since there is this 4 in front of the x, we have to use long division. So we're going to be using long division. So I'm just going to start out my long division. 4x cubed minus 15x squared plus 17x minus 6. And I'm going to divide it by, right, 4x minus 3. That's what I'm trying to determine, is it a factor. So I'm going to divide by that 4x minus 3. So, again, our first step is to divide. So 4x cubed divided by 4x, right? You get 4 divided by 4 is just 1. X cubed divided by x is x squared. So we get 1x squared, and line it up right over by 15x squared. 1x squared times 4x is 4x cubed. 1x squared times negative 3 is negative 3. X squared. Okay. Then I have to change my sign because I'm subtracting. So I have 4x cubed minus 4x cubed, so that's 0. Negative 15 x squared plus 3x squared is negative 12x squared. And then my last step is just to bring down. So I'm going to bring down that plus 17x, and I'm going to bring down that minus 6. Now let's divide again. Now I'm dividing 4 into negative 12x squared. Well, negative 12 divided by 4 is negative 3. X squared divided by x, I have 2 x's. Divide by 1x, I'm left with 1x. Now we multiply. Negative 3x times 4x is negative 12x squared. Negative 3x times negative 3 is plus 9x. Now, with my subtraction step, I have to change my sign. So positive 12x squared and negative 9x. Negative 12x squared plus 12x squared. 17 plus negative 9, you get 8x. And then my step where I bring down. Now, back to the division. Again, divide my first term. 8x divided by 4x. Well, 8 divided by 4 is 2. Right? X over x. So x is cancelled out. So just 2. 2 times 4x, right, is 8x. 2 times negative 3 is minus 6. Now I'm subtracting, so I have to change my sign. Negative, positive. 8x minus 8x cancels out. Negative 6 plus 6 also cancels out. And we get 0. For this type of question, I don't care what my answer of the division is. I care about this 0. I care that there's no remainder. Right? So in this question, if 4x minus, or if 4x minus 3 is a factor of this polynomial, our answer is yes, because the remainder is 0. And that's it. Let's look at another example. Looking at example 2. Now, I'm determining if x minus 1 is a factor of 3x cubed plus 10x squared plus x minus 6. So, now, there's no number in front of us. So here I'm going to use synthetic division. I forgot. So, I have an x cubed, an x squared, an x, and then nothing. So I'm not missing any terms. So I'm just going to write I have a 3, a 10, 1, and negative 6. There's a 1 here. And draw my box. There should be room on the bottom of your box. Your box doesn't come all the way down. We have to write stuff underneath it. Then, right, I have to change my sign. So it's x minus 1. So it's x equals 1. Right. So there's a 1 here. And now I just bring down that 3. Multiply by 1 is 3. And I get 13. 1 times 13. You get 13. Multiply, or add, sorry, you get 14. Times 1 is 14. Negative 6 is 14 is 8. Again, I don't care what my factor is, or my division part is. I just care for these questions, does it have a remainder or not? So, does it have a remainder, or is it a factor? No. Because the remainder is 8. Right? Again, just like dividing real numbers. If you have a remainder, it doesn't divide evenly. Right? So this does not divide evenly. I have a remainder, it's not a factor. Let's look at example 3. Example 3. If f of x equals 2x to the 4th minus x cubed plus 3x squared minus 1, find the value of f of negative 3. Right? So before we were technically using our factor theorem, and our factor theorem is a form of the remainder theorem, this is the true remainder theorem. If I want to find f of negative 3, all I have to do is synthetic division using negative 3. Okay? So I'm going to use all my things here. One thing I noticed, I have 4, 3, 2, and then 0 x's. I'm missing the 1x. So this is really 2x to the 4th minus x cubed plus 3x squared plus 0x minus 1. Don't forget your placeholder terms. Okay, I need that 0, else it's going to throw off my synthetic division. So then I have my numbers 2, negative 1, 3, 0, negative 1. And then on the side just goes whatever I'm trying to find the value of. F of negative 3. I don't have to change the sign for these ones. Okay? This gives me the solution. It's giving me that I want x equals negative 3. It's not giving me like x minus 3. Okay? So don't change your value for this one. And then we're doing the same exact thing. I bring down that 2 times negative 3. I get negative 6. Negative 1 plus negative 6 is negative 7. Times negative 3, we get 21. 3 plus 21 is 24. Times negative 3, that's negative 60, negative 72. Adding those, that's negative 72. 3 times negative 72, you get 210, 216. Adding those together, you get 250. And again, all you're looking for here is what your remainder is. So f of negative 3 equals 250. And that's it. Okay. All right, let's look at our next page. One more type of problem. So given x cubed minus 2x squared plus ax plus 20, and x minus 5 is a factor of the polynomial, what is the value of a? Okay. So here, I know almost all of my polynomials, but I know x minus 5 is a factor. Again, if something is a factor, that means its remainder should be 0. So all I'm going to do here is synthetic division and see what my remainder is. Okay? So we're going to start there. So technically this is 1, so I have 1, negative 2. I'm going to use that a. I don't know what number that is, but I have to use it. And then 20. Okay? X minus 5 is my factor. That means I'm going to use x equals 5, changing that sign. So 5 is going to go over here. Now I just start my my synthetic division. Bring down that 1, multiply by 5, right? That's 5. Negative 2 times 5 is 3. 5 times 3 is 15. It's a little weird. 15, right? A plus 15 is a plus 15. I can't add those, but I need that a in there. When I multiply this, I get 5a plus 75. Right. Add these together, I still just have 5a. Right? 20 plus 75 is 95. Okay. Now, again, all I care about is my remainder, 5a plus 95. Since it told us it is a factor, my remainder has to equal 0. Now all I'm doing is solving for a. Right? I'm going to subtract 95 from both sides. And then I'm going to divide both sides by 5. Right? Negative 95 divided by 5, you get negative 9. So it looks a little strange, but it is just doing synthetic division and then setting your remainder equal to 0. Okay. Again, if it's a factor, your remainder is 0. Let's look at example 5. I have x cubed plus ax minus 12. I'm talking if x plus 1 is a factor. So this is the same type of problem. But when I look at this, x cubed plus ax minus 12, I'm missing an x squared. So I really have x cubed plus 0x plus ax minus 12. So then when I set up my synthetic division, I have 1, 0, a, and negative 12. What goes on the outside comes from here. Right? I have to switch the sign. So x equals negative 1. I'm going to bring this 1 down, multiply by negative 1. 1 times negative 1 is negative 1. 0 plus negative 1 is negative 1. Negative 1 times negative 1 is positive 1. Adding a plus 1. Now I need to multiply. So I get negative a minus 1 when I multiply that by negative 1. Adding, I get negative a, negative 12, and negative 1 is negative 13. This would have to equal 0 since this is a factor. So negative a minus 13 has to equal 0. So negative a equals 13. If I add 13 to both sides, I don't want to know what negative a is. I want to know what a is. So I'm going to divide by negative 1 to get rid of that negative sign. So a equals negative 13. And that's it. So your factor theorem and your remainder theorem really is just using what we already know about division to find the remainder. All right, I will see you guys tomorrow.